So we're going to start with word problems. So there are 4-5 topics that we'll cover. We'll cover percentage, ratios. Then we'll cover compound interest, simple interest, Venn diagram. Then we have time, speed, distance, work rate. Okay, so essentially this is arithmetic. Okay, half of arithmetic would be through number problems. So this is what it is, and arithmetic plays like around 40% weightage. Okay, and it's actually increasing. We'll include little bit of algebra also in this, which is equations and functions, which is becoming increasingly important. Okay, and GMAT is moving towards that. Okay, so the weightage of these topics is increasing day by day. Okay, and it's not just the weightage of these questions. So for example, percentage and ratios, these things would help in other questions as well in terms of calculations. So they'll make calculations easier. You'll start looking at the calculation part of the question in a different way. So that's how this will help. Let's start with percentage. So one thing, the basic percentage thing is, for example, if I say 10% of something, 10% of X, that simply means X into 10 by 100. Okay, percentage means that number by 100. That's what it means. Okay. Now, so we can keep it as X by 10, or we can put it as 0.1 of X. Okay, we can convert it to decimal. We can convert it to fraction. For example, if I say 25% of X, so that would be X into 25 by 100. So I can say that this is X by 4, or I can say it as 0.25 of X. Okay, it depends what would help me with the calculations. Now, if I say X is increased by 10%, so that means to X, we are adding 10% of X. So 10% of X we know is 0.1X. So this entire thing becomes 1.1X. Okay. 1.1X simply means X getting increased by 10%. Okay. 10% more than X. If I increase it by 20%, it would be 1.2X. If I increase something by 50%, it'll become 1.5X and so forth. Okay. At the same time, if I decrease something by 10%, it will become X minus 0.1X. That will be 0.9X. If I decrease something by 20%, it would be 0.8X and so forth. Okay. So these things are important when we'll do calculations. Is that okay? Any doubt with this till this point? And let's say if I say X upon Y is equal to 1.3X, let's say, what does it mean in terms of percentage? What do you see here? X by Y is equal to 1.3, not 1.3X. X by Y is equal to 1.3. What does it mean in terms of X and Y, the percentage and so forth?
X is 30% greater than Y.
X is 30% more than Y. Okay. And if I say X upon Y is equal to 0. Let's say 8X, what does it mean? 0.8. So that simply means X is 20% less than Y.
Yes, Y is 20%.
Okay, because X is equal to 0.8Y. 0.8Y means Y minus 0.2Y. That means 0.2Y has been decreased from Y. That means 20% has been decreased from Y to get X. That's what it means. Okay. So sometimes in questions, you'll see in actual questions, in actual GMAT questions, you'll see a lot of calculation which will ask you X is what percentage greater than Y. Okay. what percentage greater or what percentage, lesser than y. So just find x upon y, that will be good enough. Can you see that? That's all we need, the ratio. Okay, because sometimes, in a difficult question, let's say when this is the final thing that we need to calculate, people go blank as to key what exactly we need to do. Okay, so it simply means that we just need a ratio, and it's very easy sometimes to get the ratio, just the ratio, and we can take it forward from there. Okay. Another thing, let's say if we have successive percentage changes. Okay. For example, x is increased by 20%. Okay. Then it is decreased by 25%, let's say. Decreased by 30%, let's say. Okay. What would be the final change? Okay. So what is happening is, let's say 100 is the initial value, just for convenience. It's getting increased by 20%, so it becomes 120. Now the new number 120 is decreased by 30%. Okay, 30% of 120 would be, just multiply 12 into 3, 36. Okay, that is 36 down. So it would be 94. Okay, 100 first got increased by 20%, it became 120. Then the new number is getting decreased by 30%, it becomes 94. So it's a net decrease of 4%. That's what it is. Right? Understood? One second, it'll be 94 or 84? 84, sorry. So it's a net decrease of 16%. Right? So see, just by looking at it, seems that we are increasing by 20%, then decreasing by 30%. Net decrease should be like 10%. No, the net decrease is not 10%, it's more, because this 30% is not happening over 100, it's happening over a bigger number. So that's why its impact would be 36 instead of 30. Okay, that's why the net decrease is of a bigger number, bigger percentage. Right? Understood? Any doubts?
Yes, sir. No, sir.
And another way, sometimes, let's say something is increased by X% and then again increased by Y%. What would be the final change, net final percentage change? Okay, so we can simply use a formula X plus Y plus XY upon 100. This is the percentage change we are looking at. It's not a formula. It's like, solving it algebraically, and then this is what you get finally. Okay, a lot of questions are based directly on this thing. That's why we are touching upon this thing. Right? For example, here, let's say it is X% increase and then Y% decrease. Okay. If it is both increase, then we'll have positive. Both would be positive. X is positive, Y is positive. Now, if it is a Y% decrease, then we'll take Y as negative. So it will finally become X minus Y minus XY upon 100 percentage. Understood? For example, it's 20% increase here and then 30% decrease here. So X is 20, Y is minus 30, it's a decrease. So, and 20 into 30 divided by 100. This is what it is finally. So minus 10 minus 6 percentage, it's minus 16 percentage. That means the net effect is 16% decrease. Negative 16% means it's a decrease. Understood? Any doubts? Okay. So if the net change is positive, it will be increase. If the net change is negative, it will be decrease. Okay. Let's come to the questions. Just open the sheet. Let's try 1, 2, 3, and 7. I mean, after 3, it starts with 7. There is this numbering error. So just try first 5 questions. 1, 2, 3, 7, 8. I mean, in that sequence. Okay. These are not very long questions. Just think, think through before you start solving, because otherwise you'll get into some messy calculations and there'll be, a problematic thing. These are like 2-step questions. Every question is 2 steps question. That's it. Not more than that. Let's do one thing. Let's try first, second, and third, and then we'll, discuss them, and then we'll take up other questions. Okay. First, second, and third. Give them a try.
Right, so 1 second and third.
First, second, third. Yeah, what about second?
So second, I'm getting confused with the calculation.
There's no calculation in second, if you see. Let's see, let's start with that second only. The annual rent collected by corporation from a certain building was X% more in 98 than in 97, and Y% less in 99 than in 99. This is what we just did. So 97 to 98, it was X% up. And then 98 to 99, it was Y% down. Okay. What we need is, what is the net change? Net change from 97 to 99, whether it was positive or negative. That's all we need. So what we need is X minus Y minus XY upon 100. This is the net change, right?
Yes, sir.
Is it greater than 0? That's what we're checking. So is X minus Y greater than XY upon 100? That's all we are checking. Isn't it? Yes or no? Right?
Yes.
Where do we get that information? No?
Yeah, I had come till this part, sir, but I was thinking how to go further. But it
No,
is
there's
there
no
in the
need to go
option.
further. No? That's all we need.
Yes.
Whether this net change is positive or negative, that will decide na? Whether it's a net increase or net decrease.
Yes.
Right? So this is
Not sure
sufficient.
first option ko how do I negate?
First option, X is greater than Y, but what we need is whether this thing would be positive or negative. For example, X is 10, Y is 11. Oh, sorry, X is 11, Y is 10, let's say. Okay. So this is what we are talking about. This thing would be negative, ultimately. Isn't it? You know, this would be 1 minus 1.1. This would be negative. Right?
Yes, sir. Right.
Right. But if X is a big number, let's say X is 20, Y is 10. So this would be positive, ultimately. Got it? So if X is a big number, in a large number compared to Y, so it could be a positive change. But if X is very close, then it could be a negative number. Understood?
Yes, sir.
Okay. See, just take it this way. Try to visualize it. This was pure, expression based. This XY and XY 100. It was based on this. Now let's take it in a very visual way. 100 is an initial number. Okay. It's getting increased by, let's say, 10%. It becomes 110. Okay. Now, if I decrease it by 10%, what would be net change? Positive or negative?
Positive, sir.
Negative. Because we are decreasing it by 11. We increase it by 10 rupees, but now we are decreasing it by 11 rupees. So it will be negative change. No?
A change would
become
be
99. Right?
Right.
Okay. Because this percentage change is happening over a large number. Okay. So if these values are close to each other, the net effect could be negative. But if these values are like 100 is getting increased by 30%, let's say, it becomes 130. Okay. But it gets decreased by, let's say, 5%. So it gets decreased by 6.5. So it becomes 123.5. It's still a positive change. Understood? Just try to visualize it this way. That's all.
Yes, sir. Understood.
Okay. Let's see the third one, and then we'll come to first. A merchant purchased. What's your answer for this? A, 0. Let's see. A merchant purchased a jacket for $60 and then determined the selling price that equaled purchase price plus a markup that was 25% of the selling price. Markup means what? Cost plus markup. Markup simply means profit. Is your selling price, right? Markup means by what amount or what percentage the the cost price has been increased. What is the addition to the cost price to get the sales price? Okay. Now, let's say C is the selling price. What is being told about the markup? Markup is what? 25% of the selling price. So this is 0.25 of the selling price. Let's say S is the selling price. That becomes your selling price finally. Isn't it? I think you made this mistake here. Maybe. Isn't it?
Yes, sir. Yes, sir. My network is slowing down, so
Achha.
I
So
understood
this is the mistake you made. Maybe you did it, you
Yes,
took
sir,
it
yes.
as 0.25 of the cost price. But it says it's 0.25 of the selling price. So cost price is 0.75 of the selling price. I mean, you take it here. This is what it becomes.
Yes, sir. Oh, selling price, cost price, my God.
So, I mean, see, word problem simply means the words will create problems. You need to, it'll trick you. It'll try to trick you, the words. Okay. So if cost price is 60, that is 0.75 of selling price. I mean, you do the calculations. How to do these calculations easily? 0.75 is what? 3 by 4. Okay. So you take it this side, selling price comes out to be 80. Now the selling price is discounted by 20%. So the final price at which we are selling it is 64. 20% down, 80% of 80, that will be 64. It's a $4 profit. Right? Okay. Any doubt? Any questions with this? Let me know.
No, sir. Yes.
Okay. Now let's see the first one. Is X% of X% of Y equal to X% less than Y? So X% of X% of Y equal to X% less than Y means Y minus X by
This answer
100.
is 1, sir. I wrote 2, I think. It is 1.
And the first one. Okay, let's see. So Y gets cancelled. I mean, if you see it, X square upon 1000, 10,000 into Y is equal to Y into 1 minus X upon 100. This is what you have. Y gets cancelled. So this is what we are checking. Are these two things equal or not? Okay. Now, if you simplify this first statement, what do you get? X square plus 100x is equal to 10,000. This is what you get. Okay. So if we compare these two things, this versus this. Okay. If you compare these two things, what do you get? Do you get something?
So this first option is 100 times. If we multiply the first option by 100, both sides, it will give us the expression that is there in the question.
100, or I mean, if you divide it by 10,000, let's say this expression, the entire thing by 10,000, what do you get? X square upon 10,000 plus X upon 100 is equal to 1. Don't you think this is what it is?
Yes, sir,
X
exactly.
square upon 10,000 plus X upon 100 equals to 1. So we were checking whether this is true. The first one simply says, yes, this is true. So this is sufficient. Understood?
Yes, sir.
Okay. So first one is sufficient, definitely. Second one doesn't tell me anything about X. And if you see, the final expression is all about X. There is no single Y here. So clearly this is not sufficient. We need information about X, not about anything else. Okay. So first is sufficient, second is not. Okay.
Yes, sir.
Okay. So that was first, second, and third. Try eighth. and eighth and 14th. Okay, 8 and 14. Try them. And 7 also. 7, 8, and 14. Try these three. Okay, let's see. So, which question you struggled most with?
So these three were okay, sir. But
Asha.
if I don't know if they were,
Okay.
if they are right.
Let's see. Let's see. If the price increased by X% from 1 to 2 and Y% from 2 to 3, what is the percentage increase? So X plus Y plus XY upon 100. This is what? This is what we're looking at. Clearly, first one tells me it is 8%. Divide everything by 100. This is what you get, that this is equal to 8. So that clearly tells me this is 8%. Okay? No doubt about that, right? Second one is sufficient. If we see the first one, X into Y is equal to 30. Now, X into Y could be like 5 into 6. It could be 30 into 1. So, we can get different answers. If we plug these numbers here, we'll get different answers. Clearly, we can't, freeze it on one single number. Okay. So this is not sufficient. Second is sufficient. So this is what it is. Let's see the eighth one. Merchant sells an item at 20% discount, but still makes a gross profit of 20% of the cost. Okay. So let's say S is the selling price and C is the cost. What percent of the cost would the gross profit on the item have been if it had been sold without the discount? Now, if it is sold at S, now S upon C would be what? Is it what we are looking at finally?
Yes, sir.
Okay, because let's say S upon C is equal to 1.3. That means selling price is 30% more than cost. So that would be 30% profit. Right? Ultimately, this is what I need.
Yes, sir.
Okay. Now, what is given? If we sell the item at 20% discount, that means if we sell it at 0.8 of S, okay, 80% of the selling price. This is given as this 20% profit, right? This is what is given to me.
Yes, sir.
Okay. So I simply need to do this small calculation so that we can get S upon C. S upon C, if you see from here, would be 1.5. So it'll be a 50% profit. As simple as that. Right? That's what you did? Or you did something else?
No, sir, exactly this.
So now if you see how powerful this small thing is. Okay. If you,
yes, sir.
I mean, if this thing doesn't come to your mind, you will be struggling with this thing big time. Not struggling, but it'll take like a lot of calculations and a lot of time.
Calculation will take longer, sir.
Right.
Changing it directly to 1.2x and
it's that simple. I mean, if you get it correct. Okay. That's why I, pointed out this particular thing initially. Okay.
Yes, sir.
Now let's see. 14th. 14th is a classic word problem question. Lot of statements, lot of twisted words, and let's see. On a certain road, 10% of the motorists exceed the posted speed limit and receive speeding tickets. Okay, so let's say X is the total number of motorists. Okay, 10% of X. Okay, they exceeded the limit. Okay, and got a ticket as well. Okay, they exceeded 10% of the total number of motorists. They exceeded the speed limit and got a ticket. That's what is given to me. But 20% of the motorists who exceed the posted speed limit do not receive speeding tickets. So let's say Y is the number of motorists who exceeded the speed limit. Okay. Okay. Y is the number of people, and only those people who exceeded the limit, the speed limit. Okay. So it says 20% of these motorists who exceeded the limit, that means 20% of Y, 0.2 of Y, do not receive the ticket. That means 80% of these people receive the ticket. Can we see that? Yes or no?
No, sir, I got it in a different way. I thought the first part is saying 10% of the motorists they exceeded and they got ticket, and the 20% they exceeded but did not get a ticket. So
Just see the language. The language is the only thing here that we need to figure out. 10% of what? 10% of motorists means 10% of all the motorists. Okay, but this is 20% of motorists who exceeded the posted speed limit.
Yes, yes.
This is 20% of only these people. Getting the point? When I say 10% of motorists means 10% of all motorists. Okay, and this is only why those who exceeded the speed limit, 20% of them do not receive the tickets. That means 80% of them must be receiving the ticket. Okay, what we need is what percent of the motorists on the road exceed the posted speed limit. This is what I need.
Yes, sir.
Okay, the people who exceeded the speed limit is what percentage of total? Isn't it?
Yes, sir.
Y upon X is the only thing I need. And can I say this number is equal to this number? Can I say that?
Yes, sir.
Yes. So 0.8y is equal to 0.1 of X. So Y upon X is nothing but 1 by 8. That would be 12.5%. Does that make sense?
Yes, sir. Actually, I made mistake with the language.
It's all about language. That's why I said this is a classic word problem question. This is the favorite part of GMAT, honestly. Okay. GMAT is known to create such kind of things. No other exam does that, honestly. It's only GMAT that plays around with words that much. Okay. And honestly, this thing, 10% of this and 20% of these, making that distinction is the only thing in such questions. Okay, and this is very, very frequently used. 10% of all, 10% of those who did this. These are different things. These are different set of people we're talking about. Okay. Any doubt? Any questions with this?
No.
Okay. Okay, now let's try 9, 10, and 13. 9, 10, 13. Try them.
10 also, sir.
9, 10, 13. These three questions. I don't know what is happening with numbers. Why are they not, in sequence? But okay. These three questions. Give them a try. So comparatively easy questions. Can we say that?
Yes, sir.
Okay. Just one second. So let's see the ninth. The ball was half full of water. So 50% full. 4 cups of water were added to the ball, filling the ball to 70% of the capacity. That means 20% is equal to 4 cups. 4 cups increase the capacity from 50% to 70%. So 20% is equal to 4 cups. How many cups of water are now in the ball? So 10% is equal to 2 cups by this same logic. Okay. If 4 cups is equal to 20%, 10% is equal to 2 cups. Now we are talking about 70% full. So 70% full means 7 into 2, 14 cups. Okay. So comparatively easy question. Okay. So, I mean, you can get these kind of questions also towards the initial phase of the question under the exam. Let's see 10th. 10th is a good question. 6-liter solution is 45% alcohol. So 6 into 0.45. So we have 2.7 liter alcohol in that. Okay. So if 2.7 liter is alcohol, 3.3 liter would be, let's say, water. Okay. Whatever the other thing is. Okay. Water or anything. How many liters of pure alcohol must be added to produce a solution that is 50% alcohol? Now we are adding pure alcohol to it, 100% alcohol. Okay. That means the quantity of water remains same. It doesn't get changed. We are not adding or removing any water. Okay. So if after adding pure alcohol, what we have in the solution is 50% alcohol. 50% alcohol means 50% water. So the water remains 3.3 liter quantity of water. It doesn't change. So if that is 3.3 liter, that is half of the solution. That means total volume of the solution would be 6.6 liter. Okay, because 3.3 is 50%, 100% would be 6.6. It was already 6 liter. Something was added. So that something must be the 0.6 liter. So we're adding 0.6 liter of pure alcohol to make so-and-so thing, whatever the situation is. Okay, that's how you figured it.
Actually, you did it in a better way. I actually calculated 0.5 into 6 plus x is equal to 2.7 plus x.
So that's like making an equation. Okay, there is no problem with that. Yes. But whenever you're adding something, whenever you are adding only one thing, okay, that makes question a little easier because the other thing remains same and you can take it as a reference point. Okay, for example, we took it as a reference point here. That is 50%, yes. So it's that remains same, so it's double is the total, and that's much easier. Okay, so remember, whenever only one thing is added, you do it this way. It always makes things easier. Okay, making equation definitely, if you're adding something which is, let's say, another solution is added, which is, let's say, 30% alcohol. In that case, you can do, whatever we did. I mean, whatever you did. Okay, making equation. 13th, see, the question is, what is the greatest number of members the club could have? Now, a number of people, number of members into the contribution is equal to total amount, which is 599. If you want to have, or you want to calculate maximum of one thing, you take the minimum of the other thing. That's it. Right? That's how it has to be in terms of logic. Right? And this minimum is 12. Okay. Now, if you have 50 members, this will become 600, but it's not 600, it's 599. So you can't have 50. So you'll have to pick the, one smaller number, that's it. Okay. That means, 49 members, some of the members would be contributing maybe more than 12. That's totally fine. Okay. But we can, so the point is we can't have 50. Okay. But we can have 49. So that is the maximum number of members we can have. right? That's the only logic we need to use. Understood? Any doubts? Any questions?
No, sir.
Okay. Now let's come to ratios. So in ratios, we see ratio as numerator upon denominator, right? That's what we see. Now, one thing, if we increase numerator, the value of the fraction will increase. Okay. And if we increase the denominator, the value of the fraction would decrease. Okay. That's one thing, we all know that. Another thing, if we have to add or subtract two fractions, let's say 2 upon 3 is getting added to 4 upon 5. Okay, either we are adding it or we are, let's say, subtracting it, whatever we are doing. You make either the numerator same or the denominator same. Okay. For example, mostly you make denominator same. So what will happen? In order to make it same, you'll have to multiply and divide this by 5, and you'll have to multiply and divide this by 3. So 10 by 15 and 12 by 15, you can simply add them to make it 22 upon 15. As simple as that. Okay? You don't take LCM and all those things. That's a time-consuming thing. That's what you do. Okay. For example, 1 by 2 plus 5 by 8 is getting added. Now you write it as 4 by 8. 1 by 2 is, you want to make the denominator same, so it becomes 9 by 8 straight away. You don't, I mean, with some practice, you'll not be required to use pen paper for this. You can do it in your mind itself. Okay. And the same thing can be used to compare the fractions. Okay. So, for example, here, you can now simply compare them. This is bigger. Okay. So here you made denominators same. Another thing you can do with 2 by 3 and 4 by 5 is you can make numerators same if you want to compare, just to compare the fractions. For example, this would be 4 by 6. So 4 by 6 and 4 by 5, same numerator, smaller denominator means bigger fraction. Okay, that's what it means, as simple as that. Understood? Any questions?
No, sir.
One more thing, very, very important. 4 by 5, 5 by 4. Okay. In both the fractions, you add 1 to both numerator and denominator. Okay. Add 1, or for that matter, add same number to both numerator and denominator. Which fraction will increase and which fraction will decrease? That's the question. Understood the question? One of the fractions would increase and one of the fractions would decrease. Which one will increase and which one would decrease? That's all we need to figure out. So, what do you see? Would you calculate and then see whether it will increase or decrease and then compare which one is bigger? Huh?
So the question is, after adding 1, we have to find out which one is increasing or decreasing.
We are adding 1 to both numerator and denominator. I mean, 4 plus 1 upon 5 plus 1, 5 plus 1 upon 4 plus 1. One in value terms, one fraction will increase and one would decrease. Which one will increase and which one would decrease? That's the question.
So 5 by 4 would decrease because we are adding 1 to denominator.
No, we are adding 1 to both numerator and denominator. I mean, this will become 5 by 6 after adding 1 to both, and this will become 6 by 5. One of the, in terms of value, one fraction is increasing, one is decreasing. Which one?
So number one is decreasing. Number two is increasing.
No, let's see. Let's see. So let's say 4 plus 1 upon 5 plus 1. 1 is what? 25% of 4? Yes. And 1 is 20% of 5. Right?
Yes, sir.
Okay, makes sense. Now, it's like numerator is increasing by 25%. Denominator is increasing by 20%. So 4 by 5 is getting multiplied with something which is greater than 1. So this fraction would increase. Can you see the logic?
Yes, sir.
Right? And the reverse is happening here. Numerator is getting increased by 20%. Denominator is getting increased by 25%. So 5 by 4 is getting multiplied with something which is greater than 1. Oh, sorry, smaller than 1. So this would decrease. Understood? Any doubt with this?
No, sir.
Okay. So it's like if the numerator is smaller, okay, and we are adding, let's say, instead of 1, any number to both numerator and denominator. Smaller numerator means the numerator is getting increased by a bigger fraction, a bigger percentage, and the denominator is getting increased by a smaller percentage. So it's like we are multiplying the fraction by something which is greater than 1. And here the opposite is happening. Can you see the logic with every kind of fraction now?
Yes, sir.
Okay, this can be used with every fraction. So if the numerator is smaller and we add something to both the numerator and denominator, this would always increase, and again the opposite would happen. Yeah. Understood?
Yes, sir.
Okay. So it's all about creating or understanding logics which are used and which would eliminate a lot of calculation part. Once it gets into your head, you'll never forget it. Okay, because this is not something complicated. It's a simple thing, but you'll have to look it from this way so that you remember it always. Okay, let's come to questions. And one more thing we missed. Let's say there are some boys and girls in a class, in a group. Okay, let's say X is the number of boys and Y is the number of girls. Okay. Now, if I know X upon Y is some fraction, let's say 2 upon 3. Okay. Can I find what would be X upon X plus Y? Number of boys to the ratio of boys to total number of people in that group. Can we find that from here?
Yes, sir. 2 by 5.
2 by 5. Okay, so it's like 2 parts boys, 3 parts girls, total 5 parts. Out of that, 2 parts are boys. It's like that. As simple as that. Nothing complicated. Okay. So now let's get to the questions. Try first, third, and fifth. First, third, and fourth. First, third, and fourth. Let's do one thing. Let's try third, fourth, and ninth. 3, 4, 9. And then we'll take other questions.
But not question number 1.
No, 3, 4, 9 as of now. After that, we'll take first. Give them a try. Okay, let's see. Third, during 1 month at a particular restaurant, 1/6 of the burgers sold were veggie burgers, and 1/4 of the rest of the burgers sold were double meat. If X of the burgers sold were double meat, how many were veggie burgers? In a question where you have fractions, and the answer is also in the form of fractions, you take total, you don't take total as something like X, Y, Z. No. Just see the denominators. 6 and 4 are the denominators. So you take total as either, let's say, a product of 6 and 4, 24y, let's say. Let's say total number of burgers is 24y. Okay. Now 1/6 are veggie. So 4y are veggie. Okay. And 1/4 of the rest. So the rest would be 20y. So 1/4 of that means 5y would be double meat. Okay. If X is the number of burgers sold, X of the burgers sold were double meat. So this 5y is equal to X. Okay. How many were veggie burgers? So y is equal to X by 5. And what we need is 4y. So 4y would be 4x by 5. Simple. Understood? That's how you did, or you did something else?
Yes.
I didn't get you.
Yes, I did it in the same way.
Acha, okay, great. Fourth is also similar. Chris' plot of land for his garage is 1/4 the size of his plot of land for his house. Okay, so garage is 1/4 of the land. So let's say land is 4, okay, and garage would be 1 in such a situation. Now further, if you see, Chris plans to sell half of the plot of land. So half of this would be sold, and 3/4 of the garage would be sold. Now 3/4 of garage would again be a fraction. We don't want to have fractions. So in such a case, you take bigger numbers. For example, you take, let's say, for house, the plot size is 16, let's say, and for the garage, it'll be 1/4 of that, let's say 4. Okay, so half of the house, that means 8 of the house is sold, and 3/4 of the garage, that means 3 out of 4 of the garage is sold. Okay, so 11 total is sold. What fraction of the land will remain unsold? 9 remains unsold out of total 20. That's your answer. Understood?
Yes.
Got what mistake you made?
I tried to make an equation, sir, assuming
if you use equation like X or something in such questions, there are very high chances of making error in such questions.
Yes, sir, this is better, assuming a number based on the denominator.
The best, not just better. See, you'll have a lot of such questions. The idea is you take total number as something which will remove all the fractions. That's your target. Okay, you don't want to deal with fractions.
Total number,
That's the main
that
point.
number should be LCM of the denominator. Then it will be not
but
a fraction.
In this case, you don't have something like that. So, for example, you started with 4 and 1. Then you see that you
then it will
still
not
have
be
fractions. Then you take this 3/4 of something. Then you take total of that as 4. Then it becomes 16. So that you remove all the fractions. So which is totally fine. Okay. So here you'll remove all the fractions, and that's, you can't make any mistake after that. Okay. All right, and then we are doing which one? 9th. Let's see, 9th. 1 can of concentrate is to be mixed with 3 cans of water to make orange juice. So 1 can of water. 1 can of concentrate is getting mixed with 3 cans of water to make juice. So how many cans of juice would be there? 4 cans, obviously. 1 can plus 3 cans will make 4 cans. Okay. So question is how many concentrate would be required to produce this much juice? That means concentrate and juice, the ratio is 1:4. Okay. That's the ratio. 1 can of concentrate is required to make 4 cans of juice. That's the thing. Okay. Now we are making 200 servings. Each serving is of 6 ounces. So total juice to be made is 1200 ounces. How much concentrate would be required for that? 1/4. That means 300 ounces of concentrate would be required for that. And question is how many 12 ounces cans can be made? So divided by 12, 25 cans of each can having 12 ounces can be made, would be required. Okay. Understood?
Yes, sir.
Okay. Now let's try questions. First and 5, 6, 7. Yeah. 1, 5, 6, 7. Let's try them. 1, 5, 6, 7. Okay, let's see. So how would you do first question? We have ratio of spirit and water in the two vessels, and in what ratio they must be mixed so that the new ratio is so and so. How do you approach such a question?
Sir, I try to do it in the same way, sir, right? Like I assume that in the first box there is 14 liters and in the second box there is 26 liters. So first box will have 10 liters of spirit, 4 liters of water. Second box will have 14 liters of spirit and 12 liters of water. Then mixing it, and then it will become 16 liters of water and 10 liters of spirit. So that's what I was trying to do.
So you're saying, let's say, how many liters? 14 liters of
It's like the ratio is 5:2. So I assume 7 liters. Iska 14 liters I did. So 10
26
liters water.
liters of B. That's what you're saying.
Yes, sir.
And but what would it make finally? That means you're taking them in one is 14:16 would be like 7:13 ratio. That's what you're taking A and B. Nahin?
Yes, sir. That's what. That is why I was not getting the answer. 7:13.
It's nowhere there. I mean, it's none of the options. Right? Okay, so let's say in first we have 5x is to 2x, spirit and water. Right? In second we have 7y and 6y, spirit and water. Okay. So A liters of this and B liters of this, let's say. Understood?
Yes, sir.
Okay. What would we get? A plus B liters of 8/5. So it's like 5A plus 7B upon, let's say, 7A, sorry, 2A plus 6B. Right?
So this part I didn't get, sir.
Okay. So what I'm saying is, let's say A liters is total in vessel A, B liters total in vessel B. So A is to B is the ratio in which the quantity is there in these two vessels. Right?
Yes, sir.
Okay. So so see, you pick just one thing, maybe. For example, you pick only spirit. Okay. So if total A liter is there in vessel A, what would be spirit in that? 5/7A?
Yes, sir.
Plus, if there is total B liter in vessel B, the spirit would be 7/13B. Isn't it? Right? There is total B liters in vessel B. So 7/13 would be ratio of spirit to total. No?
Yes, sir. Yes,
Okay.
sir.
What does it make? 8/13 of A plus B. That's what it makes.
Yes, sir.
Does it make sense?
Yes, sir. Yes.
Okay. Now you just do rearrangement. 5/7A minus, or let's say 7/13B minus 8/13B is equal to 8/13A minus 5/7A. So do rearrangement of that. That's it. So you'll get A by B ratio from that. But this would be
Sir, but
negative
how
here.
did you write it directly in the first time? Like without doing all this calculation?
We have not done any calculation as of now. I mean, which part you're saying?
It was the first time when you read this expression, and I told you that I didn't get this part. You could write
Which?
directly at one.
So we are just simply taking A is the total A liter of vessel A and B liters of vessel B.
Yes, I got it.
Got it. But there seems to be some problem with the numbers here because this comes out to be negative here.
Yes, the final answer is not coming.
Because it'll be a negative expression, 7 by 13. And this would would this also be negative? This, that's totally fine. So let's write this whole thing again. I mean, this would be like minus b upon 13. Okay. And what would this be? You multiply this by 7, multiply and divide, that'll be 56 by 91a minus, multiply and divide by 13, 65 upon 91a. Okay. So minus b upon 13 would be equal to, this would be what? 9 by 91? Minus 9 by 91a. Got it?
Yes, sir.
Okay. So what you get is actually this would be 7b by 91. We can write it as multiply and divide by 7. So a upon b would be 7 upon 9. Understood?
Yes, sir.
Okay. So, I mean, if you have to, explain it in 2 lines, a liters of that, b liters of that, and this would be a plus b liters ultimately when we'll add. Okay. And the idea is this is spirit to water ratio 5:2. You just simply take spirit to total, which would be 5 by 7. Okay. Spirit to total 7 by 13. Spirit to total 8 by 13. That'll make life easier. Right? So 5 by 7 of A, this is the spirit, quantity of spirit. 7 by 13 B, quantity of spirit in vessel B. And ultimately, we are making 8 by 13 of A plus B. So spirit in A, spirit in B is total spirit. Okay, spirit in vessel A, spirit in vessel B is equal to spirit total. That's ultimately what you're doing. Understood?
Yes, sir.
Okay, because if you take both the things, spirit and water both, it'll make things complicated. It'll make things complicated. Now, this is like one simple equation, and after that, one more step, and you're done. Okay, make sense?
Yes, sir.
Any doubt, any questions with this? And that's how we'll do, all other questions which are similar to this. For example, there are 2 more questions like that, right? Fifth is also similar to this. Ratio of boys to girls is 2:3. So let's say A is the number of people here. So 2 by 5A, ratio of boys to total number of people. Okay. 4:5 would be 4 by 9B, let's say. Okay. Understood? This would be 4 by 9, ratio of boys to total number of people. Okay.
Yes, sir.
You add these two, what you get is 3 by 7 of A plus B. That's what you get. Right?
Yes, sir.
Okay. And from here, you can calculate anything that you want. Okay. Let's calculate. So this would be 2 by 5A. I mean, we have little weird numbers here, 5, 9, and 7. So let's calculate 2 by 5A minus 3 by 7A and 3 by 7B minus 4 by 9B. So, I mean, if this would be 14 by 35A minus, multiply, divide by 5, 15 by 35A multiply and divide by 9, 27 by 63b, minus multiply divide by 7, 28 by 63b. So minus a by 35 minus b by 63. I mean, subtract. So a upon b would be 35 upon 63. That would be 5 by 9. Okay, so number of people in A to number of people in B is 5:9. Right? Understood?
Yes, sir.
Okay. So let's say so what we need is finally ratio of number of girls in class A to number of girls in class B. So let's say there are 5 people total in class A. So there'll be 3 girls out of that. Okay. And there are total 9 people in B.
Yes, sir.
So there'll be 5 girls out of that. So 3 by 5 would be that ratio. Simple. Understood? We're taking just one step ahead, this whole thing.
Yes, sir.
From question 1. In question 1, we are supposed to calculate only this thing, in what ratio those people must be added. And, we are particular about, the ratio of girls in class A to girls in class B. I mean, just another 10 seconds, not more than that. Okay?
Yes, sir. Understood.
Understood? All right. Now, getting a hang of these questions?
Yes, sir. It is. Question wise, they're easy, sir, but calculation is taking a little bit of time.
But if you do it this way, like milk to water in this is
This
3
way
by
is
4.
better.
So let's say A liters here, B liters here. So 3 by
Earlier, I was
7A.
calculating both, taking both water and spirit, so making 2 equations.
If you take both, it'll be difficult. Definitely,
That's
will
it
be
took me
very
longer
challenging.
for all these equations.
So this is what you get. Equal quantities of water and milk. I mean, the ratio is 1:1 finally. Right? So 5 by 7b minus 1 by 2b is equal to a by 2 minus 3 by 7a. Okay. So 10 by 14b, I mean, you multiply divide by 2 here, multiply divide by 7. 7 by 14b is equal to multiply divide by 7, 7a by 14 minus multiply divide by 2, 6 by 14a. Right? So 3 by 14b is equal to a by 14. Sorry, this 3 would be there. So a upon b would be equal to 3:1. That's it. Now, if you see, it'll not take more, it'll take less than 1 minute. Once you get a hang of what exactly we need to do. Understood?
Yes, sir.
Questions? All right. All right. What other question we are doing? That's it? Okay. Let's do 2 more, which would be question number 8 and 10. Both are good questions. Okay. Give them a try.
Right.
Okay, let's see. So, okay. 8 says in a demographic study, the population total income of a certain region were estimated from other data. Both estimates had upper limit and lower limits. The times of the estimates was the per capita income in the region greater than 16,500. Per capita income is total income upon total population. That is what this per capita income is, right? So is this greater than 16,500? That's what we are checking. Okay. First one says lower limit for the estimate of the population. So population minimum was this. This clearly is not sufficient. It doesn't tell me anything about the income. Lower limit for the income was so-and-so. This is clearly not sufficient. It doesn't tell me anything about the population. If we combine the two, okay, so income upon population. Now, what we have is lower limit. What does that mean? This is the minimum value that we can have. Do we have any upper limit given in the question? Do we know the upper limit? Do we know what maximum it could be? Do we know the upper limit?
In the question only. Upper limit is in the question itself.
No, but we don't know the value now. There must be an upper limit, but there is no value given to me. What do I take it? So what it means is, that means there is no upper limit given to me. Now, if I keep increasing the numerator, okay, that is the income value. That means value of the fraction will keep going up. Can I take some value of income so that this ratio becomes more than 16,500? Can I take any value which will make it more than that?
Yes, sir.
No? We can. Now, if I keep increasing the denominator, the population value, can I take some value which will take the value less than 16,500? Can I take some value?
Yes, sir, up to the lower limit.
I mean, anything above lower limit I can take now. So I can take
Yes,
some
sir.
value of the denominator, which will take the value of the fraction to be less than 16,500. Even combination is not sufficient. I can take values which will make it more than this. I can take values which will make it less than this. I don't know. E would be the answer. Isn't it?
Yes, sir.
So E is the answer. I mean, for that matter, be it 16,500 or any number for that matter. I cannot compare this fraction to any number. I can't compare it to even 1. Because I can take some values which will make it less than 1. Understood? These values that these are given, these are just a trap. Doesn't matter what these lower limits are, doesn't matter. Okay, understood? Any doubts?
Yes, sir. No, sir.
All right. Now let's take for 10th, let's take the weighted average concept. So what happens in weighted average? So let's say there is a class in which I think you have done weighted average in some stats maybe earlier.
Yes, sir, we did it in numbers first.
Stats, we did in statistics.
And statistics part.
So I'll briefly take it through. So let's say there are some boys in a class, there are some girls in a class. Let's say the average score of boys is 40. Average score for girls is 60. Question is, if we merge them, what would be the average score of the class? So if there is one boy and just one girl, what would be the average of the entire class? 40 plus 60 by 2. That would be 50. Okay. Now, if we have 10 boys, let's say, and 10 girls, what would be the average of the whole class? So total score for boys would be 10 into 40. Total score for girls would be 10 into 60. So 400 plus 600, that's total score. And total number of people would be 20. Average would still be 50. So if number of boys is equal to number of girls. Okay. Average would be exact midpoint of 40 and 60, which is 50. Exact. It's like a weighing pan again. So if weight on both the sides, so number of boys is the weight here, number of girls is the weight. So if the weights are same in both the pans, the average would be exact midpoint. Okay, that's the concept of weighted average. Now let's say if there are more girls or more boys, okay, then this pan will not be, this needle will not be exactly in the middle. So if we have, let's say, more girls, so the pan will tilt towards this side and the needle will be this towards this side. Okay, so that's the whole concept of weighted average. For example, let's say average for boys is 40, average for girls is 60. After we club them, after we merge them in a single class, let's say after merging, the average of the entire class is 55. Let's take any random number. That means it's not the midpoint. Okay, it's closer to the average for girls. Okay, so remember, needle will shift in the direction of the heavier pan. Okay, towards the heavier pan. That means we have more girls here. Number of girls is more than the number of boys here. What we can do is just make this cross. Okay, this difference is 5. This difference is 15. This will give you number of boys to number of girls, the ratio of number of girls to number of boys. I mean, number of boys to number of girls, which would be 1:3. Okay. So the boys and girls must be merged in this ratio so that the final average is 55. That's what it means. Does that make sense? Right?
Yes, sir.
Now, if we come to this question, it's exactly the same thing, weighted average question. So what it says is, it says, see, wherever we are merging two things, we can use it for mixtures also. Okay, wherever two things are getting merged, boys and girls, two mixtures are getting merged, just see if we can use weighted average, and especially for DS questions. In a certain senior class, 72% of the male students and 80% of the female students. So remember, for males, the average score was 40 and 60 in the example that we took. Here we have some percentage, 72% of males, 80% of the males, do something, do the same thing. Okay, they've applied to college. Okay. What fraction of the students in the senior class are male? Male is to female ratio. That's what we need to calculate. Now, if we know what percentage of the entire class have applied to college, okay, whatever these numbers refer to, if we get that same number for the entire class, for example, in second, it says 75% of the students in the whole class have applied to college. Can we find this ratio? Yes or no?
Yes, sir.
So this would be sufficient. We don't need anything else to find this out. Understood?
Yes, sir.
Okay. See, even if you don't do it by weighted average, it's like, let's say X is the number of boys, Y is the number of girls. So 0.72 of X, okay, plus 0.8 of Y.
Statement 2 is simply saying that 75% have applied. We know the percentage, but that percentage has to be calculated on the number, no? So that's why
that's what I'm saying. Let's say X is the number of boys, Y is the number of girls. Okay. So 0.72 of X, 0.8 of Y is equal to 0.75 of X plus Y. That equation is fine, first of all. Yes or no?
Yes, sir.
Can we find X upon Y from here? Yes, we can find. We don't need numbers, we need ratio, end of the day. Isn't it?
This is where I got confused.
We don't need number. We need percentage or the ratio, finally. Second statement would be sufficient. Okay, understood now?
Yes, sir.
Second is sufficient. First simply says 840 is the total number of students. Out of 840, how many have applied to college? We don't know. So clearly not sufficient. The first one. So B would be the answer. Okay, make sense?
Yes, sir.
Okay. All right. Now let's do compound interest and simple interest. When I say compound interest and simple interest, in terms of the maths required, it's almost very similar to what we did in percentage. Because when we calculate interest, it's nothing but it's a percentage change. For example, I invested 1,000 rupees. I got, let's say, 10% interest in 1 year. What would be the total amount that I'll get after 1 year? 1,100. 1,000 plus 100 rupees interest, which is 10% of 100, right? That's what simple interest is. It's simple percentage change. That's it. Okay. The situation changes when we have compound interest. Okay. So, for example, there are two things. First of all, let's try to understand what is compounding. So, let's say with simple interest, we invested 1,000 rupees. Okay, at 10% rate of interest, annual rate of interest. In first year, okay, after first year, okay, and end of first year, you'll get 1,100 here, 1,100 here. Okay. After second year or end of second year, you'll get 1,100 plus 100 rupees. The interest amount remains same. I mean, interest, that 10% is calculated on the same amount in case of simple interest. So 1,100 was there at the end of first year. I'll earn same interest, 100 rupees at the end of second year. So I'll make 1,200. I mean, this would be the amount that I'll receive. Okay. In case of compounding, this 10% would be calculated on 1,100. So the interest I'll get would be 110 rupees. So 1,100 plus 110 rupees. So that would be the total amount that I'll get at the end of the second year. Understood? Right? That's the difference between compounding and simple interest. Because in simple interest, your interest, which is 10,000, is calculated on the same principal amount every year. But in case of compounding, after 1 year, this is the amount that you got. Now the 10% would be calculated on the entire amount, okay, on the principal amount plus the interest that you earned after 1 year. Okay, so this interest would be calculated on the previous interest that I got. That will make the whole difference. This 10 rupee difference is 10% of 100. That's what it is. Okay, so this will make the whole difference in case of compounding. Understood? Any doubt with this? So let's do 1 or 2 questions and then we'll get to know what exactly it is. Let's try first, second, and third. First, second, and third. Gone through both the questions? All three?
Yes, I've gone through all the questions, sir. I'm getting confused the formulas.
There is no formula required, honestly. Let's see. The first one, difference in simple interest and compound interest on a certain sum of money in 2 years is at per annum interest rate is 50. What would be that sum? So first year, second year. Okay. So compound interest and simple interest. So let's say X is the amount. So after first year, the interest would be 10% of X. In case of compound interest also, in first year, the amount is X. Okay. So the interest would be 10%. Is that okay, first of all?
Yes, sir.
Right. Now, second year, in case of simple interest, the interest amount remains same, 10%. Okay. But in second year, the interest would apply on two things. One is 10% of X, okay, the amount, and will have 10% of the interest that I earned in first year. 10% of 10% of X. Is that clear? Understood?
Yes, sir.
Okay. Now, the difference means, see, in first year, it's same, so there is no difference. In second year, this part is same. So this part will not create any difference. Difference would be created by this part. So 10% means 10 upon 100 into 10% of X, 10 by 100 of X is equal to 50. Now, if you see, this is X by 100, X would be equal to 5,000. That's it. That's all. Understood?
Yes, sir.
So there is no big calculation involved.
No, this one I could do, sir. This one I got correct.
Acha, this one was easy. Okay. Let's see the second one. The compound interest on a certain sum of money for 2 years is 208. And the simple interest for the same time at the same rate is 200. Now again, first year, second year, simple interest, compound interest. Now for simple interest, the interest amount remains same for both years. So if in 2 years, I got 200 simple interest, that means it's 100 each. Okay. Now in compound interest for first year, it's going to be 100. It's going to be same in first year. In second year, the interest would be calculated on this part, sorry, on the whatever the sum is, okay, and so that part would be 100, okay, plus interest would be calculated on the interest that I earned in first year, which is 8 rupees. The difference would be calculated only in the second year. I mean, it will be created only in the second year. So 8 is the difference. So what would be, I mean, 8, this difference is created because interest is calculated on the interest that I earned in first year. So this must be 8% interest rate. Did you get that?
Yes, sir.
Okay, because the interest that I get on the interest of the first year, that would be the difference. So 8 rupees I earned on 100. So the rate of interest must be 8%. It's very similar to question number 1. That's it.
Yeah, here I started putting formulas, so I got.
No,
actually, if you go by logic, then it is easier.
It's simple logic. GMAT will not test you on big formula. That's the first condition. Okay, it will not check you on those things. So
yes, sir.
That's the thing. Third is very simple actually. 5,000 invested for 1 year at P% simple annual interest yields 500. So rate of interest P must be 10%. Okay. What amount must be invested at K% simple annual interest for 1 year to yield the same number of dollars? I mean, to yield 500. So the interest amount and the principal amount, let's say X is the amount into K%. This must be equal to 500. Okay, that's the thing. Now, if I know K, I'll get X from here. Okay, K is equal to 0.8 of P P is 10%, so K would be 8%. This is sufficient. Second one also says K is 8. I mean, that straight away says, so this is also sufficient. D would be the answer.
Yes, sir.
Understood? That's pretty simple, actually. Okay.
Yes, sir. That is
There's no calculation involved. Huh? Try fourth. Fourth is a very, very good question. Give it a try. How is second sufficient?
So like second, it is saying 16% total. If we take, I took
More than
8% as
16%.
a.
It's not
No,
16,
I
it's
took.
more than 16.
No, we just need to find out, na sir, ki was R greater than 8, was R greater than 8%. So if I take R to be 8%, my total interest is coming to be 166 compounded.
Okay. Let's assume it's getting to be 166.
And that is more than 16% of $1,000. So
See,
B
if
is
I
also
say
correct.
X is more than 16, Y is more than 16, can I compare X and Y?
Okay, that way.
Got the point?
Yes.
Let's see this whole thing. Joanna invested 1,000 at annual rate of interest, R%, compounded annually. She kept the amount invested for 2 years, and the rate of interest was same for both years. Was the rate of interest greater than 8%? See, if it is 8%, if the rate of interest is 8%, then with simple interest, okay, we'll get 80 rupees in first year interest, 80 rupees in second year interest, okay, with simple interest again, okay. Now, so for 2 years, with simple interest, the rate of and the interest amount would be 160. For compound interest, okay, in case of compounding, the rate of interest for second year would be slightly more. So rate of interest for 2 years would be slightly more than 60. I mean, how much more than 60, we don't have to calculate actually. Okay. So it'll be more
So
than
we
60.
can, but otherwise calculate. No, it will be 8% of the interest. So 8% of 80
Well,
will
that'll
come
be
out to be
6.4. We don't have to calculate. That's the point.
Yes.
What you're saying is totally fine, but we don't have to calculate. Okay. First says the total interest earned after 2 years was 163. So interest amount is given. If I do back calculation, can I find value of R from there? Can I find?
Yes, sir. Yes, sir.
Yes, I can find. So can I compare that value with 8%, whether it'll be more than 8% or not?
Yes, sir.
Yes, so sufficient. I don't have to calculate. That's the beauty of data sufficiency. We don't have to calculate. Okay. From here, I can calculate our rate of interest definitely. So I'll be able to compare it whether it is more than 8% or not. Okay. Will not get different values of R from here. Okay. That's the whole point. We'll get one single value of R from here if we do back calculation, and that would be sufficient to compare with 8%. Second, total interest earned after 2 years was more than 16% of the amount. That means total interest was greater than 160. Okay. So compound interest would be greater than 160. This says greater than 160. It's same way. X is greater than 160, Y is greater than 160. Can I compare X and Y by that logic? I can't compare. Okay. See, it will be more than 16%. It will be more than 160. Now, we know with 8%, this would be 166.4, right? The interest amount. But, you know, from this information, more than 160 can be 161. It could be 170. So in this case, it would be smaller. In this case, it would be bigger than 8%. Understood? So
yes, sir. I got this
logic,
logic, but it is saying that it was more than 16%. So more than 16% can be anything, but at least it is 16% more than the initial amount. So we can say that it was greater than 8%.
No. With 8%, the interest actually for 2 years would be 166.4.
Yes, sir.
That means with 7.999% also as rate of interest, I can get after 2 years more than 16%. I mean, cumulative of 2 years. I can get.
Yes, sir. Understood.
Because it is compounding. Understood? So, see, with 8%, it will be 166.4. That means with slightly less than 8%, it can still be more than 160. Right? So
yes,
we can't compare it with, whether it'll be 8% or more. We can't. Okay. So that's why this is a very, very good question. Okay. See, again, we don't have to do any calculations. That's the best part of this question. We can use it, we can solve it just by using simple logic. Okay. So